Hi, my name is Jonathan Charles, and welcome to the video on SD-WAN policy configuration basics. So we're going to basically review those SD-WAN policy architecture and configuration basics and basically how they're distributed, where they're going to get attached to the system, and the order of operations. The order of operations ends up being relatively important here so that we make sure we classify the correct traffic and then act on it. So basically, when we're done with this, you'll be able to describe how that policy architecture works and what the basics are of the configuration and how they're distributed, attached, and what the order of operation is. All right, so we use the following high-level policy constructs. Control policy definitions enable us to define how sites and VPNs interconnect based on the routing information. For example, you can define a control policy to prioritize transport MPLS for all traffic to a given VPN. So if you have MPLS versus internet, we can prioritize that MPLS circuit versus falling back to the internet connection. Data policies, on the other hand, modify data flows based on the properties of the IP packets or the flows themselves. An example, you can define a data policy to route a particular application over a firewall. Each policy type is going to exist as a centralized or localized as follows. Centralized policies are basically provisioned on the centralized vSmart controllers on the overlay network and affect the entire network. Right? There's one active centralized policy, and that's applied to everyone. All right? Even if you are not being affected by it, you still get that policy because it's a globalized, centralized policy. So what we would basically say is all VPN 3 sites can communicate directly with the data center only, like a hub and spoke topology, and everyone gets the policy even if it doesn't apply to them. However, a localized policy affects a single edge device, right? So we can create a localized policy and apply it to just one site. For example, on site X, use a special ACL, and it's applied to just that device. Okay? So all the centralized policies are applied on the vSmarts. Basically, you assemble those, the following 3 building blocks to configure a policy. We need to define groups of interest. Who is this going to be taking effect on, right? And we can define those via prefixes, site IDs, TLOC IDs, VPN numbers, colors, and whatever SLA we want to set up. Basically, we create this list, a group of interest list, and then we reference the group of interest list itself instead of each individual prefix or site itself later. Basically, if we have to change the group of interest, we just change that group of interest thing and we don't have to rewrite the entire policy. Basically, we're going to define our groups by adding members and referencing those groups when we build the policies. And policy definitions are our next step. Those are going to define basically what we're going to do with the people who are that we defined previously. We can have policy definitions that control aspects of control and forwarding. Control policy for routing plane or control information. Application-aware policy, so if you have specific types of traffic, we can route it in different directions. Or data policies, about who can talk to who, basically. We also have policy definitions that control other aspects, VPN membership for limiting the scope of traffic to specific VPNs. Or a CFlow flow monitoring template, where basically we look at the traffic flow itself and we make a determination from there. So policy application controls what a policy is applied towards, all right? So we've created a group of interest, which is some type of traffic. We've decided what we're going to do with it, and then we say who we're going to apply it to and what direction, okay? So it's going to be site-oriented and is defined by that site list that we just created earlier. So a policy is basically the sum of one or more lists, one policy definition, and at least one policy application, as shown in this figure up here. The figure lists the specific policy configuration keywords that you use to define lists and policies and to apply to the policy. All right? And we'll go through this. Obviously, we're looking at this at a 10,000-foot level. Once we zoom in a bit more, it'll make a lot more sense. All right. So how do we do this? Well, we go into configuration, and then we centralize policy, and then we add a policy. All right? And this will define a new centralized policy. So this is going to apply to everybody. If one already exists, we can choose a policy and modify it, or we can deactivate one and activate another. So very first step is we're going to create groups of interest. That's where we define the lists to which the policy will apply. We configure topology, and VPN membership is where we'll define the control policy. All right. So it's actually describing this right here, the next step, and then we're configuring traffic. So basically, we're going to create the groups of interest. So it could be any of these guys up here, right? Then we're going to configure a topology, so that could be hub and spoke, or it could be any-to-any or a full mesh. And then we configure the traffic, the data policy. A policy always consists of a control policy and a data policy. If you do not need one of the policy types, it just remains empty. Okay? So to configure those groups of interest, we'll choose the list type in the list column. All right? So let's say we're looking at an application here, such as an application, VPN, color, prefix, and so on. Example on the slide defines application for which the policy definition applies. We have options that are built in already for Google apps and Microsoft apps. We can click a new application list to choose from an exhaustive list of applications and to create your own grouping. So if the application you're looking for isn't in the list, you can add it by protocol and port. Because these application groupings are not yet used in a policy, the reference count is currently 0. So this reference count here shows you what policies they're applied to. After you set up these groups of interest, we're going to click Next at the bottom of the screen to move to the Configure Topology and VPN Membership step. Okay. Referencing an IP prefix through a list instead of directly by setter notation provides a layer of abstraction. So later, when the objects themselves change, the policy, so branch 31 here, all right, remains untouched because the policy uses object lists rather than the objects themselves. Okay, so we'll define a prefix list using setter notation, all right, from our group of interest list, either by using the existing list or by defining a new prefix list. Enter a name for the list to be referenced in the policy definition later, and then here we're adding in the setter notation, and then after each prefix we'll click Add. And what it'll do is it'll start adding these to this list at the bottom, okay, with their prefix list name and list. So what you can do is you can actually go into this later, this master prefix list, and modify it as you choose instead of actually having to go in and delete the entire thing and starting over. We can also group by a site list. All right, so remember each site has an ID. So if we have a site ID 3, we can actually create a site list and include those sites in that list. So for example, let's say our data center is site 1 and 2, right? We have 2 data centers. And then all of our branches are cited numbered 10 through 50. Okay? You can add this as a branches reference later, and then reference branches, and it would automatically include that entire list of sites. Okay? In this case, 40. It doesn't have to be all-inclusive, so if some of those numbers don't exist, it doesn't matter. It'll actually apply them. So if like 11 doesn't exist, 10 through 50 will still include all the other ones. And we can also do VPN numbers. All right, so let's say you have globally VPN 2, actually let's just say VPN 10 equals voice VLAN. Okay? We can create a list that's called voice, or guest in this case, all right, references VPN 10 at every single site, and then we can act on just that VPN. For example, let's say we don't want that VPN to have access to anything on the network, but we want to give them internet access, for instance. We could actually reference them as guests, right, and then say the corporate VPNs, which are 1, 2, and 3, those are allowed access to the data center, whereas this list is not, for instance. Okay? All right, the next step, we can create TLOCs. For each TLOC entry in the TLOC list, you enter the following attributes. The TLOC IP address of the vEdge router. All right? So this is that system ID that we're going to be referencing for that site. We can also reference the color, the protocol, and which path priority we're going to be using. The higher the priority, the higher likelihood that we're going to use that path over any other. So if you have 3 paths, we need to tell the device in some way which path is better than the others. By default, all of them are 0. So if you add something as 50, and then it becomes a relative list, right? So if you have 3 that are 0 and 2 that are 50, it's going to try to load balance across the ones that are 50. And if those both go down, right, we're then going to fail over to the other ones. Remember, we're not saying don't use the ones that are 0, just prioritize the one that's higher, and if it's currently unusable, we'll move on to other ones. Okay? And then click Add to the list. So after all those, by the way, all of those we were discussing is just creating groups of interest. How do we define our source traffic that we're going to match this policy to, right? Because remember, we can match it against all those settings, and there's a bunch of other ones as well, including QoS, DSCP settings, etc. Then what we do is we create a topology, right? There's built-in ones of hub and spoke, okay, which is the 1990s, you know, everybody has a point-to-point back to a hub. Full mesh, right, which is any-to-any. And then custom control. We're probably going to be using hub and spoke and custom control probably the most, because generally what we're going to try to be doing here is moving traffic through some centralized site, in which case we're hub and spoke, or some sub-definition of hub and spoke. And when we talk about regional breakouts, where you've got something for North America and something for Europe and something for Asia, we don't want those sites routing to another continent to do services when they have those services locally. And this is where we'll be creating those custom control topologies. All right, and this is the definition in the control policy. So we're going to be using this and referencing this topology in the policy itself. Okay. So once we have a topology definition, once you create a topology definition, we have to include a name and a description. And topologies are defined for each VPN. Therefore, a topology definition always begins with the VPN list. Okay? So we're going to want to create VPN lists prior to this. You can't add VPN lists in here. You have to do it prior in the previous pages, and then you can reference them from here. Okay? So what you're going to do, let's say we selected hub and spoke, which is here. We basically say add hub site, and we say, hey, hub site is data center. Spoke sites and then branches before, when that site list of 10 through 50. Now we're referencing it. Now we have a hub and spokes. This is now we've defined the topology for the environment. Okay. So remember, one key thing there is you're going to want to plan this out in advance because you can't add stuff here on this page. You're going to want to do it on the previous one. Create all your groups of interest first, then you can add them here. The whole goal here, by the way, is to maintain some kind of higher level of abstraction in the definition and to facilitate changes later. That way later, I can go back and change my groups of interest without modifying the policy, right? Because I'm not going into every single step. I'm going and saying, okay, you know what? I need to add, we now have added 10 more branch sites. I'm going to update branches to include 10 through 60 now instead of just 10 through 50. And then I don't have to redo the entire policy. Okay? And now we're defining a traffic data policy. Okay? So basically there's 3 high-level types of data policies that we're going to be using. Application-aware routing, route this application through this location. A traffic data policy, which basically says who can talk to who. And a CFLOUD policy. We'll talk about each of these in more detail, okay, under the traffic rules place. So right now we're going to create a traffic data policy, okay? And we're going to configure some traffic rules. And after, so back here we enter a name and description. Where is it? There it is. Up here is the name and description, which is actually, they skipped a screen. So we're actually, yeah, you'll see it. When you get to the labs, you'll see how these are actually defined. So then we're actually going to add a sequence number. All right. We'll click sequence type, choose the type of data. So we have our application firewall. We have QoS, service chaining. Service chaining, by the way, is dropping a firewall into the path of traffic or an intrusion prevention system or some other type of device. Okay. Traffic engineering is where we change the routing of traffic. And then we can actually create custom policies that, well, basically, we can get pretty specific to what your needs are. Okay, these are the most common, so they're actually pre-canned for you. Once you've created the policy, once you've finished it, you activate it. Remember, we only have one active policy on the entire system, so if you can have 20 policies, but only one of them can be active at a time. Remember, because these are centralized policies, they're applied to everyone, right? Regardless of whether they apply to you, you still get the policy. You just don't do anything with it. And when we look at the router, when we look at the actual CLI config that's pushed out, this will make a little bit more sense, okay? And basically, remember these 3 dots. When you see them, that means that there's going to be a menu on the, for actions we can take, okay? And once it's active, there'll be a deactivate button there too, okay? Now it's defined and activated, and now you can go, if you wanted to, you can go back and edit it, all right? So if you wanted to edit, you can edit a bunch of stuff, the list, the topology, and the type of traffic. Okay? So we're going to be using vManage to define and manage all the policies as follows. You always deploy these centralized policies on those vSmart controllers. So up here, okay? We're going to configure them on vManage, and they're going to be pushed to the vSmarts. Okay? The vSmarts will then push them to the vEdges. The centralized policy is going to be sorted by site ID and direction, in or out, from the perspective of vSmart. Okay? A localized policy, which we haven't talked about yet, are going to be deployed directly on the vEdge routers where the policy is required. The direction is from tunnel 0 or from service VPNs. So from tunnels always means VPN 0, and from service is always VPN 1 through 511. Okay? Note the directions in red arrows here. It's important to notice in which direction a policy is applied. And we're going to use vManage to distribute these policies. Basically, vManage is going to send all these centralized policies, those text boxes in the slides, to vSmart. And the centralized policies are not sent to the vEdges. vManage sends localized policies directly to the vEdge. And basically, the configuration that we're using is netconf yang. If you're not familiar with it, it's a method of pushing out in a Python-esque methodology of configurations. Okay? All right, so several policies might affect any given packet. Therefore, we're also going to need to understand the order of operations on this slide. Okay? Basically, we're showing 3 ingress policy operations in their sequence, followed by a routing and forwarded decision, and then 2 egress policy operations. All right? We can perform DSCP marking and forwarding class mapping through access lists and centralized data policies, in which case the centralized data policy overrides the classification and marking done by the access lists. You can perform path selection by app-aware routing policy and centralized data policy. If a flow or packet is matched by app route policy and the centralized data policy, then they both try to select the path on the transport based on policy definition. Then the data policy overrides the path selection by the app route policy. Okay? Notice the service side and transport side concepts here. Okay? Remember, this is inside. And I know I'm hammering this a lot because at the end of the day, if you don't understand that concept that VPN 0 is always the transport side, it gets a little confusing when we start configuring interfaces. All right? So very first, we start off with the local ingress policy, so policing, admission control, classification, and marking. Then we use our centralized app route policy for SLA-based path selection. So if we have multiple paths, which path we're going to select based on SLA, jitter, latency, etc. Then our centralized data policy for policing. Remember, we can have a local policy versus a centralized policy, so it's which one takes precedence here. Okay? Because we can do classification and marking at both the local ingress and the centralized data policy. Let's see. And then routing and forwarding is going to be after that, and then we do queuing and scheduling. Queuing and scheduling is going to be pretty late in the game because we want to make sure we're actually starting to put packets on the wire. And we also do support low latency queuing for real-time voice and video. And then our access list, policing, and remarking. Okay? So remember, all policies are going to be defined and managed on vManage. Centralized policies are going to be distributed through vSmart. Localized policies are going to be distributed directly to the vEdge devices. They have directions in and out for control policies and from service and from tunnel for data policies as seen from the vEdge. A well-defined order of operations occurs between policy types, and multiple policies might affect a given packet. Thank you for watching this policies overview. Stay tuned for more detailed videos on policies.